In part 1 to part A of the KSP quiz, we are asked to write the equilibrium constant expression for the given equation, which is simply Pb2 plus the molarity times I minus squared, and it's squared because there is a coefficient of 2 in the chemical equation. For part 2, we need to find the molar concentration of I minus, which can be done simply by multiplying 2 by the given concentration for Pb2 plus, which is 1.3 times 10 to the negative 3. And so for that we get 0.0026. And so now we have to find the value of the equilibrium constant. And so using the expression and the I minus and Pb2 plus values, we get 8.8 times 10 to the negative 9. The I minus value is squared, once again due to the 2 coefficient from the original expression. In part B, we are asked what the molar concentrations of Pb2 plus and I minus would be in a solution of 2 liters instead of 1. And so we didn't learn this before the quiz, and I'm still kind of fuzzy on it, but my understanding was that it would be the same as before due to the molar ratios staying the same when changing volume while dealing with solubility or saturation. I'm really not too sure. I think this is correct. In part C, we are asked if the molar concentration of Pb2 plus would increase, decrease, or stay the same if solid NaI was added to PbI2. So the answer would be decrease due to the equilibrium shifting away from the Pb2 plus, because whenever you add in the NaI to PbI2, you're just increasing the amount of I in PbI2, and so the equilibrium shifts away from Pb. In part 1 to part D, we are asked to calculate the molar concentrations of Ba2 plus and CrO2 minus in 1 liter of solution with given information. And here we divide the 8.2 times 10 to the negative 6, which is the molarity given, and we divide that by the 500 milliliter value we're given to get 4.1 times 10 to the negative 6. So this is our new molar, or this is our new moles. And so we can divide, or this is our mole value, and so we can divide that by the new volume, which is 1 liter, and we still have 4.1 times 10 to the negative 6, which is the new molarity value for Ba2 plus and CrO2 minus. So for part 2, we are asked to prove how a precipitate does not form given the information above. And so for this, we find our Q value, which is done by multiplying our Ba2 plus value times our CrO2 minus value. And so that is the molarity values. And so from that, we get 1.7 times 10 to the negative 11. This value is less than the KSB, or the KSP, for the salt BaCrO4, which is 1.2 times 10 to the negative 10. And since our Q is less than our Ka, then no precipitate is formed.